I deployed the same AI project with Go and Python. This meant developing the same project twice, once in each language. Why, you ask? Because bugs will only scare you once, and we like to keep our coding horror stories bilingual. The project was a recommendation engine with multi-armed bandits that was responsible for personalizing the whole discovery screen for hundreds of thousands of users. The implementation needed to be fast, scalable, and efficient in resources, so deploying in a language that can achieve that is key. But though Go is famous for its speed and efficiency, it wasn't as straightforward as it seemed. You see, I had this recommendation engine working in Python as a cron job for some time now, and it resulted in a noticeable increase in revenue. However, we wanted to make this recommendation engine more dynamic, responsive, and have them update every time the user refreshed their screens. I went with using the Fast API library to create my serving API in Python. Most of the code was written in Pandas and NumPy, two highly efficient libraries written in C. The last function was the only one without Pandas and NumPy, using a for loop to deduplicate elements, rearrange items, and handle promotional requests. Despite trying to make it faster, it took up to 60% of the response time. But that wasn't the big issue, as the response was around 400 milliseconds locally. The issue came when we tried to deploy on 5% of users. The response time was not as expected, and it kept increasing till it reached 5 seconds. We had to scale the number of pods in Kubernetes up to 46 just for this small percentage of users. This small percentage had a lot of concurrent requests per second, but that meant that to fully deploy to all users, we needed over 920 pods. When I brought this up with the DevOps team, they made me feel like this.
$100 billion.
The next day was the start of the weekend, and I decided to take a break. Psych, I didn't. I needed to find a way to handle this fast, as this project might be postponed till further notice because it's not impactful enough, and I really wanted to dump my spaghetti code for this cron job aside. Since Python's implementation had little room for improvement, I decided to switch to Golang. I had seen a team successfully make this transition at my old company, and our backend team already uses Go daily. My goal was to learn Go as quickly as possible and then rework some parts of the recommendation engine. This would allow me to report back on Monday with the performance difference between Go and Python and get everyone on board using Go on this project. I started by getting a taste of what Golang can do, so I created a function to sum up the first n numbers in Python and Go and found that Go was a whopping 100 times faster. This was reassuring, so I started learning the basics of Golang from a fast YouTube video as quickly as possible. Then, I jumped straight forward to developing the recommendation engine. In the process, I relied on ChatGPT to help me write some code, translate code from Python to Go, and even explain a couple of concepts to me. It wasn't always producing the correct code, but it sure helped me move faster. Along the way, I used structs and Go interfaces to structure my code, and it came naturally since I used design by contract in a lot of my data science code. I also found a NumPy alternative called GoNum and a Pandas alternative called Gota and Go Data Frame. I was happy to find all the functions I needed were available in those Go packages. I used group by, merge, and aggregate functions. Every function I searched for was supported. I kept working on the project until our Monday meeting, but I hadn't timed or tested the code yet. During our meeting, I suggested trying out Golang, but there were concerns about the time it would take to redo it in Go and the availability of all Python data science libraries in Golang. A senior backend engineer also mentioned that most of the Python code is already optimized in Pandas and NumPy, and that we won't see much difference between the two languages. He was partly right, but more on that later. In the end, I convinced them to see the runtimes of the Go code I already have and decide from there. After the meeting, I compared Python's runtime with Go and found that Go was 30 times slower. Wait, what? The backend engineer was right. Pandas was highly optimized and its Go counterpart was so much slower. Surprisingly, what took Pandas 9 milliseconds to process took Go data frame more than 330 milliseconds. But what if I ditched data frames and merged and aggregated data by using structs, maps, and loops? I mean, the experimental summation function was 100 times faster than Python, so it might reach Pandas performance. I restructured the data into a map of structs using the merging column as key. I also implemented the merging and aggregation functions by hand, but it was worth it at the end when I saw the code that I've written was 3 times faster than Pandas. And Go's overall runtime was 10 times faster than Python's. We kicked off Go's version for 5% of users using the same 46 pods, and it ran smoothly. Scaling up to 10%, then 50%, then eventually 100% of users on the same 46 pods showed it would handle the load effortlessly. Go not only showed superior response times, but also exhibited better control over resource management and concurrency, crucial elements for the project's scalability. However, it's essential to note that while Go excelled in these aspects, it doesn't encompass all the data science libraries we might need. And some libraries might exist in Go, like Go Data Frame, but are not efficient as Python's implementations. Moreover, working with Go demanded some more code and time in development. I would move away from Python only if it fails to handle the amount of traffic being thrown at it. I hope you enjoyed this video and have a wonderful day.